is GATE 2017 set to electrical question number 42. A 25 kVA 400 volt delta connected 3-phase cylindrical rotor synchronous generator requires a field current of 5 ampere to maintain the rated armature current under short circuit condition. For the same field current, the open circuit voltage is 360 volts. Neglecting the armature resistance and magnetic saturation, its voltage regulation, that is in percentage with respect to the terminal voltage when the generator delivers the rated load at 0.8 power factor leading at rated terminal voltage is being asked. For NPTEL reference, you can refer to lecture number 90, Open Circuit and Short Circuit Test on Synchronous Generator of the NPTEL course Electrical Machines Part 2 by Professor Taposh Kumar Bhattacharya, Department of Electrical Engineering, IIT Kharagpur. Coming to the useful data, this is the phasor diagram of a synchronous generator under leading condition. So in leading condition, you see the value of EF as found from the phasor relations is the magnitude can be determined as Vt cos phi plus Ia Ra whole square plus Vt sin phi plus Ia xs whole square for lagging condition, and leading condition it will be minus. Okay. Now the value of synchronous reactance as determined from the short circuit test is EF by ISC, that is short circuit current for the same field current. EF is the open circuit voltage for that field current for which you perform the short circuit test to circulate the rated current in short circuit condition. Please understand that it is for that field current only. The I field is constant, so that voltage divided by that short circuit current gives the value of the synchronous reactance. Now in synchronous machines, Xs is much greater than Ra, that is armature resistance. So we can consider the magnitude of the synchronous impedance actually the synchronous reactance. That's why EF by ISC gives Xs. Actually it gives Zs, but Ra effect is so less that we actually find the magnitude of Xs. The percentage voltage regulation is then given by open circuit EF minus that terminal voltage divided by terminal voltage into 100%. Coming to the solution, it is given that it is a 400 volt delta connected synchronous generator and the power rating is given as 25 kVA. Now I rated, that is rated current is 25 into 10 to the power 3, that is power, divided by root 3 into 400 volt, that is the line voltage. So line current can be determined as 36.085 ampere. Now this is the line. I want to find the phase current. So I phase rated can be determined as 36.085 divided by root 3 ampere. So this is coming out as 20.83 ampere. When you perform short circuit test, this is EF, this is Xs, and this is Ia in short circuit condition. So you take the single phase equivalent circuit where all parameters are in per phase parameters. So you take the per phase quantities and do the analysis. So now Xs can be determined from the short circuit model as EF by I rated for same field current of 5 ampere. So that condition, the EF value is given as 360 volts divided by, we find out I rated per phase is phase, but is that is 20.83 and in ohms. So Xs value can be written as 17.28 ohm, that is in per phase. Now the value of E can be determined as root over V cos phi plus Ia Ra whole square plus V sin phi. Now since it is leading, we take the minus sign, Ia Xs whole square. Now all are in per phase quantities. So V per phase is V line in delta connected machine. So 400 into cos phi is 0.8 plus Ia should be per phase taken 20.83 into Ra, that is the armature resistance. Now that armature resistance value is neglected as it is being asked in the question. So this whole square plus V into sin phi is cos phi is 0.8, sin phi is 0.6 minus Ia, which is per phase. So 20.83 phase into Xs per phase, that is 17.28 and then we have the whole square of this whole root over. This value is coming out to be 341.76 volt. Therefore the voltage regulation percentage obviously is 341.76 minus 400 divided by 400 into 100%, which is coming out to be minus 14.56%. It is negative for leading condition. So now the percentage voltage regulation is minus 14.56%. This is the answer.